Hello, everyone. Before we begin the formal presentation, I'd like to take you through some of the features of this webinar. Many of you have been here before, but for those of you who are new, if there are any issues at all, please use the question field on the side of your screen in the control panel. I will try to help you with any technical difficulties or queries. We'd encourage you to ask our presenters any questions that you have when you think of them. To do so, also use that question field in the control panel, and I'll be looking at those. I'll be monitoring those the entire time. As we move from section to section, if I think it's a good idea to ask those questions at that point, I'll stop our presenters and ask them to address the questions. Otherwise, there will be time for questions at the end, but please don't hold on to your questions. Go ahead and ask them as you think about them. You'll receive an email tomorrow with a link to the recording of this session. And please also keep in mind that there's a handout section. So the slides that they're using today are available in a PDF format right there in the handout section. So please take a few minutes even right now to go ahead and download those handouts. Finally, there's a short survey at the end of the webinar. Please take a few moments. It's only 6 questions. Shouldn't take you more than about 20 to 30 seconds to fill those out. It's really helpful for me as the organizer, but then also to help the folks here from Averbis get an understanding of what your interest might be in their product. And so without any further ado, welcome to episode 6 of the ML4Patents.com webinar series, this time featuring Averbis and their Patent Monitor product. I'm Tony Trippi, founder of ML4Patents and Managing Director of Patent Informatics. And I'm joined today by Cornel Marco and Hanno Epson from Averbis, and I'm going to allow these gentlemen to introduce themselves and jump right into the presentation. Take it away, guys.
Thanks, Tony. So good evening and good afternoon, everybody. Great to have you here. My name is Cornel. I'm one of the founders of Averbis. So we started the company almost 15 years ago in 2007. We are located in Freiburg, Germany. My background is computer science and computational linguistics, and I'm very happy to give this webinar today together with Hanno. So I pass it to you.
Thank you, Cornel. Yes, I'm Hanno. I'm at Averbis for, I think, now 2 years. I'm responsible for customers and customers to be. Before that, I have a 15-year career in the pharmaceutical consulting area. I will switch my video off for saving bandwidth. But Tony, thanks for hosting this interesting series of webinars. The last episodes were quite interesting, so we watched them, and we hope to reach the same high standard with our presentation today. Cornel and I, we split a little bit the duties, and I take care about the general aspects of Averbis and the more general aspects, and also be there for the customers or viewers who don't have much experience with machine learning. And Cornel will give you detailed insight and a live demo, and also present the qubit challenge. Also, others mentioned that in the series before, that patent and literature classification is a knowledge and effort intense task. Whether you do FTO analysis, patent monitoring, landscaping, you have to deal with increasing number of patents, complex keywords and queries, and you get too many hits that are not relevant to you. So it's time consuming and not really satisfying, and your experts are really drowning in work. So Averbis has a vision that we want to give you the time back that you can concentrate on the important tasks. And we think we do that through a unique combination of machine learning and advanced text mining. In the best case, integrated in your processes and systems. We will come to that later. But let me introduce Averbis first. So Averbis is not a startup company anymore. As Cornel said, we are 15 years at the market. We started in the healthcare and life science sector, therefore most of the customers are from that area. We have hospitals as customers, other software companies, a big pharma and biotech and medtech part, but also authorities like the European and the Swiss Patent Office, and also other IP service providers like Centre Doc, Econsite, XPAT, and so on and so on. So what do we do at Averbis? We deal with large piles of text, large amount of text, and we can basically do two things. We can sort large piles of journals, articles, and patents by using machine learning and natural language processing. That is one part. And the other part is we can detect and extract concepts from the text. On the right-hand side, you see a short example. And for those who are not familiar, I take you through. So these are a text, it's not a patent, it's PubMed, it's scientific literature. And we can detect diseases like myasthenia gravis and drugs, avelumab. And we do that by using terminologies, and we detect abbreviations and so on and so on. So we can build on top of that more complex, we call that annotators. For example, if a drug mentioned beneath a disease with some keywords, for example, in resulting in, we mark that as an adverse event or safety event. And by this, using that principle, we build more complex annotators, which we can show you later, that helps also in the patent space. How do we help our clients? We use these two capabilities for scientific literature classification and review, for sure. We have a module that detects adverse events and pharmacovigilance. We can do systematic literature review, technology and competitor scouting, or extracting data from regulatory documents. You see also a nice quote from Nicolas. We are pretty proud of that. He is also not only into our technology, but also in the way we work and collaborate with customers. Today, we are looking into the patent search and monitoring. So let's take a look at the patent monitor. We built the patent monitor to automatically classify large number of patents and non-patent literature into 3 definable categories. It's browser-based, but it can be also installed on premise. That is sometimes also important for our customers, that the data doesn't leave their buildings. The patent monitor imitates the behavior of your IP experts, and it learns from your input. In the machine room, under the hood, we are using 4 major functionalities to do that. Bottom right, we use terminology, state-of-the-art terminologies. In the medical sector, it's ICD-10, for example, METRA, MESH, LOINC, ULMS, and so on and so on. And then we have on the top left the text mining capabilities. I explained that shortly before. And with these 2 capabilities, we immediately have a semantic search solution. So you can look for cancer, and it will also find metastatic things and so on. So all the synonyms and things are covered. Number 4 capability is the machine learning. For those who are not familiar with machine learning, I will shortly explain how that works from a user perspective. In the traditional approach, you have your patent database, and you do a search query. You create a search query that could be quite complex. So I saw pages, maybe 1-2 pages of complex and or Boolean queries. And the computer execute that query, and you get a patent result list out of it. So that is the traditional approach. Machine learning works differently. So we use supervised machine learning. You define your categories, and you have to provide examples for each categories. And now the computer doesn't execute the query, but it creates a model that can distinguish between those categories. So step 2 is you take your patent database or a primary patent research, and you apply the model to that, and then you get a patent result list sorted in the categories and also with confidence values. I will come to that later. The computer creates his own model, taking various aspects into account, like title, abstract, sometimes full text, applicant, etc., etc. And that is freely configurable. So what does the classifier offer? It basically offers to label a patent with a certain category. For example, it's a tire patent, so a car tire. That is a single label scenario where every patent gets only one label. It's a tire or a steering wheel or none of them. We can also offer a multi-label scenario where, for example, a patent can be a tire patent and a car patent. So it has multiple labels per patent. The easiest scenario, which is widely spread, is the binary scenario, where there are only two categories. For example, relevant, not relevant to me, or my portfolio, not my portfolio. And this might be a scenario where you heavily want to look into. But we can also provide multiple category or non-binary scenarios, like, for example, covering technological areas. This is what we implemented at the European Patent Office, where, for example, every new application is scanned through our machine and then sent to the right department at the European Patent Office. Here you can see another example of a multi-category scenario. This study analyzed the development of world-class patents for different technological areas, for example, recycling, wind energy, vaccines, and so on, across various countries and timelines. And with pure keyword search, you could it's, I think, basically impossible that you can capture the relevant patents for these areas. I did a research on wind energy, and there will pop up patents for steel poles for wind energy, but they are not really world-class patents for wind energy. So with the freely definable examples, you can narrow down also these technological areas. We also offer a confidence value. So you get the result list and you get the confidence value. And this describes how sure the model is, in plain words, how sure is the model that this is belonging to a certain category. So you can sort your results via confidence. And if you want to work with the results, then you probably pick the examples or the results with the highest confidence values. But if you want to improve the classifier, you pick the examples with the low and medium results. Here, the system and the classifier can learn a lot when you tell them what was the right answer. 2 years ago, we presented a paper, a study at a conference at Würzburg, optimizing neural network for patent classification. This research was until then, or showed the best published results until then using CNNs. But for normal or standard patent classification, we use support vector machines. Why? You basically need fewer training examples. You can train fast and you get fast results. You don't need a lot of computing power, so you can do it on your laptop. And that is also important for some customers. It's repeatable and deterministic. When you use the same set of training data, you get the same results. And Cornell will show it to you later. With a little linguistic pre-processing, we achieve very good results in fast, 10, 15, 20 minutes. You can look at the qubits results later. How to get started? We wanted to make it as easy as possible. And here's what you have to do. Define your target categories, be it single label, multi-label, binary, or multiple categories. Provide 10 to 20 or 30 examples for each category, depending. In a binary scenario, for example, take 30 per category. Train the classifier. Let the system classify additional documents, and then you have your first results, and then you use the feedback loop, or as we say, iterative learning, to improve the classifier and the results. It's easy and super fast. With more examples, the classifier even gets better. To make it easy and convenient for you, we combined everything into a nice graphical user interface where this is highlighted, where you can manually label patterns or classify automatically without coding or any clue about machine learning. Now, Cornell will take over to show the qubits challenge and give a live demo. And questions, Tony, I think.
Yes, fantastic. First, plug for SVM. It's a method that I've used for a couple of years now. Wrote a blog post several years ago about using a support vector machine in doing binary classification, the difference between recall and precision. I've been saying for quite some time that I think that they're separate problems. So I deal first with creating a high recall set. Then separately, I deal with the issue of how do I increase the precision within that high recall set. And I find that using the support vector machine is a very straightforward, simple way. It can be done very quickly. Multiple iterations can be done in a half an hour, an hour. It really doesn't have to take a lot of time. And in the end, it produces very, very, very good results. The things that score very, very high are always very relevant. The things that score very, very low are always very irrelevant, and it saves me a tremendous amount of time. So just a quick plug, generally speaking, for the support vector machine method of doing this. But yeah, let me ask a few questions here before we move into the demo. I think it's relevant. I'll take them in order. Can you talk a little bit more about the data source used in the system? And then there's some sub questions about data harmonization, coverage, currency. I think those will depend on what your answer is. And I've had an opportunity to use this system a little bit, so I think there's a couple of ways to answer that. But what is it as far as data sources? What can the system handle?
Yeah, so we don't provide content. Yeah, so we don't sell patent information. We hook on what is available at customer sites. So for our demo purposes, we have a connector to IFI claims. We have also a connector to PatBase. We have Elastic or a Kafka integration where you can hook on existing databases or data lakes at customer sites. So that is from a technical aspects. Cornell, do you want to add things?
No, so we will also see it in the demo, and then also at the end of the webinar. I think we have a slide covering this topic, so how to integrate your own data into the application.
Fantastic. Okay, so and that would mean then with the currency, the coverage, and the data harmonization, that's all dependent on the source of the data that is being put into the system, and that's completely up to the user. So the second question is, how does the system work with non-English languages?
Well, the easy answer is, so if you train the system, let's say in German, and you categorize documents in German, then it's the same procedure. So the approach itself is kind of language agnostic, with some drawbacks maybe for Asian languages. And also what the system does not offer is to train in English and then to classify German documents. So this is what the system cannot do. Yeah. So usually we are working with machine translated documents, and many database provider, they already come with machine translations of the documents, but there's no separate built-in solution for translating documents.
Okay, great. Couple more here. I think you addressed this, but I guess I want to ask it just to make sure. Does the categorization system automatically create additional training data besides the user provided data? Then there was a question about the algorithm, which we know is SVM. And I guess also, actually, this comes into being with the multi-label. And when you're doing something other than a binary classification, when you're doing a free classification, as it's referred to sometimes, how many records per category? I mean, is it generally what you said as far as anywhere between 10 and 30 is enough? You want to talk just a little bit about multi-category classification and how many records it might take to differentiate those categories?
So let me start first.
Oh yes.
Yeah. So I think first part is for me and easy. Maybe I understand it. So we encourage our customers to start small, provide some examples. You mentioned 20 to 30 or 10 to 30, and then run the classifier, and then you get automatically categorized results. And I think it's far easier to approve these results and have then extra training material. So I think that works well for a single label binary scenario. Cornel, you cover the multi scenario.
Yeah. So for multi-label scenarios, you usually need more training examples because it's more difficult to distinguish between the categories, which is also the case if the categories are not well defined or if they somehow have an overlapping semantics. So the more complicated it gets, and also if we as humans have more and more problems in agreeing on our decisions, then the same is true for the machine as well. But as Hanno mentioned, so our approach is what we call active learning. So we start with few training data. We receive quality measures from the system, so we will see it also in the demo. And for the predictions that the system makes, it's a good way to approve the top 10, top 20 predictions with the highest confidence, if they are correct, and make corrections there. But also to screen for the predictions with the lowest confidence, because this is where the machine can learn most out of you as an expert. So instead of arbitrary labeling training data, so randomly, the system guides you to examples where it can get most out of you as an expert.
Excellent, great. And yeah, I think that can't be understated. This is machine-assisted work, and the best results always come from a dynamic interoperability between the user and the model. And the more input you provide to the model with regards to those sort of in the middle category, in the middle documents, the more likely you are that's going to end up with a classifier, end up with a model that's really fit for purpose and is going to do the best job of organizing the content the way you want it to be organized. One last question. I think this one is a little bit off the classification topic, but I still want to make sure it gets asked. To which extent does Averbis, so what have you folks found with regards to using ontologies and thesauri that are associated with scientific literature? And if you apply those to patent text, what's your experience been with the application of those sorts of tools, ontologies, and thesauri, and applying them to a different data set?
I think you will show it, Cornell, right?
Yes, I will show it very briefly afterwards. But in general, those thesauri and terminologies, they play a very important role for us and for our customers. As Hanno mentioned, so we are very active in the life science area, and there are many standardized terminologies. So we have to map the content and the information in the documents to concepts in the terminologies and ontologies to enable semantic interoperability. And we also use these terminologies for patent information, and this works very good, just to identify the relevant concepts within the texts. Yes, so the answer is yes, we can incorporate them, and they play a very important role for us. So it's very nice to have both the machine learning part for document classification, and then to focus on the relevant results, and then to further deep dive into the content of specific documents. And this is then where terminologies applied to natural language processing is really a huge benefit. So. Right. Then I switched to the demo and the qubit challenge, and I'm sure that Tony will assist me if there are any questions about this specific data set. So the qubit data set is publicly available. It's a gold standard designed for evaluating machine learning based categorization solutions. You can find the set here in the internet, and the set consists of, well, two categories. So it's a binary scenario. There are relevant documents and not relevant documents. Relevant documents in these collections are referring to qubit generation, and I'm absolutely no expert in this area. Some important keywords here are also superconducting loops, topological, quantum, dot-based, and ion trap methods. And not relevant and not in scope in this scenario are quantum computing patents referring applications, algorithms, and not mentioning any hardware components. Is that right, Tony?
Yeah, that's close. I'd say that the not mentioning a hardware component isn't totally accurate, because I think some of the negative, and that was the thing, there were 500 positives, 500 negatives that were like quantum computing but not hardware. So that's the one part. But then there was the other part that might even involve the word qubit, but it's not qubit generation. So it might be a hardware component for doing something else. And so what you said here is basically right. But I mean, the distinction between hardware, yes or no, is not entirely accurate. And of course, as I've mentioned before, I find there's a continuum in relevancy. The apples to astronauts, which is very easy to do. Apples to orange, apples to fish, which is both food, apples to oranges, both fruits, and then Macintosh versus Fuji, which are both apples. And so you get a harder and harder problem as you move down that continuum. And so the qubits that was set up for some apple to fish and apple to orange ones for the negatives, and didn't go anywhere near trying to distinguish ion trap versus topological, for instance, which would have been your Fuji versus your Macintosh. So yes, very good.
What we can see here is that it's definitely difficult to define some keywords matching these categories. So because there's no clear separation between these two sets. So if you go to the collection, then this is what you will see. So it's basically it's a list with the corresponding class. So there are negative and positive examples. Then the family number, then a patent ID, the title of the patent, and the publication date. So this is the input that we have for our scenario. In all, there are 5,000 unique patents, and mapped to families, there are 1,500 unique families with 430 positive examples and 990 negative examples. And what we did, and this is something that we do very frequently for support vector machines, is that we do some balancing on the training set. If you have more negative examples than positive examples, and here it's the double value, then you will train a small bias towards the negative ones. And therefore, we balance the set, and here resulting in 430 positive and negative examples. But we evaluated both scenarios just to have the comparison, and this is the overall result. So what you see that we achieve 94% overall, both for precision and recall, because every false positive in the one class is at the same time a false negative in the other class, and vice versa. So 94%, which is really a very good value, but no difference between these two data sets. And if we dive a little bit deeper, then we will see that having this balanced data set, we will have a higher recall for the relevant ones. And this is what you usually want to achieve. You don't want to miss relevant documents. And this is why it's worth to do this balancing here. So we are very happy with the results. These are great results. So next I want to show you how we achieved this. I switch to the application. So this is how the application looks. Yeah.
Yeah. There's three questions in the chat. The audience, thank you so much. You guys are great. This has been fantastic. But one I want to ask before you do the live demo, because it's particularly specific to what you just said. How did you select the balanced training set? So what did you do to cut down from the 990 something in the negative set, and then out of that take 435? So what did you do?
Random. Yeah.
Okay. Fantastic. Thank you. Please continue.
Okay. So this is how the application looks like. So, as Hanno mentioned, it's browser-based. I can log in. You can run multiple projects in parallel. I already created the qubit project. What you see here then is how to, well, feed the system with documents, so it's sources, and then to do everything with this classification. If I go to this classification page, you see there are no documents in the system yet. So the question is how to feed the system. Here I'm using a connector to the IFI claims database. So I create a new connector, and I want to import the positive examples. And therefore, I take the patent number. So this is the list of 435 positive examples, patent numbers. I paste them here. I do the same for the negative examples. And I create a third set, also for testing and for demonstration. So I query the IFI claims database for the latest 1,000 patents containing the word qubit. Okay, so now the documents, they are imported in the backend. So we are fetching the full text from IFI claims. Then what Hanno said, the first step is to create the category labels. And we do this here in this component label system. So I create a new label called, I already did it before, relevant and not relevant. But you're free to define your own category scheme. Then let's go back to this classification page, and we already see there are documents in there. So there are no labels, so no category assignments yet. We see we have 435 in the negative sets, then 435 in the positive set, and 200 qubits, and this will be further populated in background. So now there are 600. So it takes some time to fetch the data, the full text data from IFI claims. I can also click into one patent here. So you see we have the title, the meta information, abstract, description, and also the claim section. So nothing special here. The second step was to provide training data for each of these categories. So you can go through these documents and label them. You can try to identify good examples for your categories by using the search. Or what we do now, since we already have this information, so we filter for the collection. So I first go for the negatives, 400, and I will label them in a batch. So I can do this on a document level, labeling. So this is not relevant. Then this will appear in blue. Blue means this is manually assigned label. So now I'm going to label all of the patents in this collection. So they are all not relevant. So I save this. This information will now be synchronized with the search index so that you have the filters up to date. So I remove the selection, and we now see there are 435 approved, and the rest is still unclassified. Now I go for the positive examples in the set. Oh, I've forgot something very important here. No. was just confused whether there are not English documents in there, but this should not be the case. So 430 documents that are relevant. So I label them. Again, this will be synchronized with the search index. I remove the selection. Now I have 870 approved, and this is a distribution. So now this is my training set. So I can now click here on this symbol to train the classifier. And now I make a little bit more detailed. So I go to this classification configuration. What you see here, so first of all, this takes a couple of minutes. So I click on the train button. But what you see, there is a default classifier. So this is a default configuration, which works in most of the cases. You can have multiple classifiers for one project. So you give it a name. You can select the features that you want to use for the machine learning procedure. And usually it's title, abstract, descriptions, and claims. You can set some parameters and make it a single label or a multi-label scenario. I will not go into details here. So the model was outdated, it was training, so I refresh. The model now is ready. And if I click here, then I receive feedback from the system. So we have now 95% precision and recall. How does it work? So this is the result of this cross-validation procedure. So again, the system takes 90% of your training data, trains the classifier, and tests the remaining 10%. And this procedure will be repeated 10 times. So every patent in your training set will be classified and predicted once. So this is how you really get reliable information on how good your classifier is, how consistent your training data is, and whether to maybe add some more training examples for specific categories. So here we can really be happy about the results. I switch back to this classification page. I'm now interested in those documents that are unclassified, 1,000. So they are all the latest 1,000 documents containing the word qubit. Again, I can classify them on a document level, or I classify the whole batch of 1,000. So this takes a short time for initialization, and now we have the first results. Red means a low confidence, rather low confidence. Green means a high confidence. And what low and high means, this is something that you can configure in the configuration. So there was one threshold parameter. The status is unclassified. So if I refresh them, we still have 200 documents that are unclassified. 11, 0, yes, because they are all now auto-classified. And what you then usually do, you go for those documents with a high confidence, then for the relevant ones. And also, of course, you can sort them via the confidence values. So it would be now up to Tony to assess whether these predictions are correct or not.
Yeah, we skipped that section.
Yes, of course. One last thing, maybe, because we were talking about using terminologies and how to well, extract concepts and keywords. This is exactly what we did. So we've added another filter with keywords. So these were some terms that have been extracted. So for the relevant documents, it's about, of course, qubit and quantum computing, but also about the superconducting qubits, quantum dot ion trap. And on the other side, if we go for the not relevant documents, then we have something like, well, quantum channel, quantum algorithm. So this, at least roughly, this corresponds to the categories that have been defined. How does this work? So I switched the window here. This is what you see from Patent Monitor if you have administrator rights. So you can configure the search, the text analysis process. Not going to details here, but you can also curate your terminologies. And this is what we did here. We set up a very simple terminology on quantum computing terms. Basically, we used the entries that we found in Wikipedia because we have no other resources at hand. So if you're curating word lists, term lists, glossaries, or whatever you have, so you can upload them to Patent Monitor and use this information for generating further well, filters, content-based filters. So that's it. That was the demo.
Okay,
I guess
well,
there are some questions. Then, if
yeah,
not,
no, that's
we
great. This is perfect
continue
timing.
with.
Yeah, no, perfect timing. We're at 12:50, just about. There's a couple of questions in here. If there's other questions, let's go ahead and queue them up. We'll get to a few of them and then finish right on time. So first question is the automatically extracted terminology used in the support vector machine in addition to the input text, or is the SVM only working on the terminology obtained from each document? So the question is interesting. I mean, maybe this speaks a little bit to the generation of the vector.
Yes.
And what it is that you might be doing in order to generate your vectors to put into the support vector machine.
Yeah. So actually, we did some experiments in the past whether we should only the concept features instead of the text document, and as a result, we saw that it's always more beneficial to use the text. So we do some more or less simple linguistic pre-processing on the documents. But at least if you have a few training data, then you'll better with using the texts. You can add the concepts also as features, but solely using concepts is not a good idea. So this is our experience.
Okay. Yeah, and the user has some control over that generally in systems of this type. The type of information you decide to feed to the system will have a big impact on how the system's going to be able to work and differentiate. All right, next question here. How good is the system for specific and accurate topic like categorization of documents that only relate to 3D printing into subcategories? Now, I think we've addressed that to a degree. And so this sort of, I guess, gets to what you were talking about. I think if you took only qubit generation, so you took the 500 positives and tried to divide it up into topological versus ion trap and so on. And so I think you've shown this to a certain degree, and you did some of it with the ontology, but do you want to speak to very specific subcategories when the general topic matter is all in one area?
Mm-hmm. So difficult to answer in general. In the end, it's an empirical question. So the answer is we have to try it. And the good thing is that you receive feedback from the system, so you know how good your classifier is, and whether your training did make sense, even if you have more complex category system in the back. So the answer would be, let's give it a try. We have to assess it in an empirical way.
Yeah, I mean, that's the whole business of Fuji to Macintosh or Quantum Dot versus Ion Trap. I mean, sometimes you get lucky, and there's they're described very differently. The method of generation for creating a qubit is going to be very, very different. The words that are associated with an ion trap are freezing, and I mean, it's a very different environment. And so the problem becomes a little bit simpler. But if 90% of the terms are the same, and there's a very small delineation between how you separate those two very specific things that are very, very similar to one another, well, that's a tremendously difficult problem. And I think that's been my experience as well, is that a little bit of trial and error can help to at least get you part of the way there. The last question that we have for the time being, please, if there's any other questions. Oh, okay, so we just got another one added as well. So this next one. So share with us a little bit about the confidence threshold. You mentioned it, it's configurable, but in your experience, in your practical experience, what should people be setting it at? Should they be changing it after they train the model once or twice? Tell us a little bit about the confidence threshold and how people should use that in practice.
Yeah, it depends a little bit on the use case, whether you want to achieve a high precision or a high recall. So you want to have a high recall, definitely for FTO analysis. So you don't want to miss anything. So you will set a lower threshold there. If you're doing landscaping, where you have many documents in your collection, and you want to have a higher precision, or if you do competitor monitoring, so you don't want to get false alerts, so you only want to see what's really relevant, then you would set up a higher precision. Unfortunately, there is no way to set the threshold value that is useful and valid for all of the scenarios. It depends on this single multi-label scenario. It depends on whether you want to achieve a high precision and high recall, and then it depends on how good your training data is and how well distinguishable your categories are. So there you have really to make an empirical assessment, to play a little bit with the confidence value. So I believe there is no way in setting it for that, in a sense that it's valid for all of your projects. Our experience for binary classification is so for 80% to make a distinguish to there at 80%, which is definitely a good starting point, I would say.
Tony, may I interfere here? There are some slides left, and we don't want to show it, but I think we should guide the audience what they can find in the handout there. So Cornel, if you jump through the next 3 slides very quickly, we provided some numbers from real examples, real customers, where you can see what are the number of patents after primary research, what are the 11 hits that are removed, what are the remaining ones, and what kind of amount of time you could save. The next one is a scenario that was a defined test set. We don't even know the question. The customer did it. And on the right hand, there are the relevant patents. On the left hand, the non-relevant. And the blue line is our prediction. And the next one,
this also corresponds to the question about the threshold. So where to set the thresholds for achieving high recall or high precision. But what we can see that the confidence value, they correspond to the actual relevancy quite well in this scenario.
Next one is we are happy that Merck presented that in October, a scenario with us, Mindsoft, and Merck, where they did a poster at the AR Star, where they also show the accuracy and the reduction of effort they achieved. And I think the next slide is one of the most important ones. How do we integrate that into your daily work? So you can use that as a standalone application, as Cornell showed it. We can integrate that into your environment, hook up to your data lake, and hand over to your patent application. We, since this month, have a full PAT-based and PAT-KM connectivity where your classifications will pop up in the alert section at PAT-KM. So the user doesn't even know after initial installation that the patent monitor is used. And SentreDoc, a Swiss company, integrated that fully in their Rapid 5 system. So you have a variety of options to work with our patent monitor classification. I think not making a big deal out of it, but I think you should know how you can use it.
That's great. No, those are fantastic. And I was going to give my own personal example of the time savings, but you've demonstrated that. And speaking of time, we are just about out of time. I guess there was one last question. I guess I do want to answer it. If maybe we could get this in 30 seconds or less. It looked like when you were talking about putting in the additional words that you generated from Wikipedia, it looked like you were using those just to be able to sort of create subcategories within it. Were any of those terms, or was any of that thesaurus building that you did incorporated into the support vector machine model, or were those two things? Yeah, they were separate.
They were separate,
yeah.
Yes.
Yeah, so they build on each other. So that's very helpful. I mean, that's very useful because the model, you allow it to use the data, work at its own ability, but then the ability to evaluate by being able to find things specifically what you might be interested in and looking at those. I think that can be very powerful. Gentlemen, we are right up on 7 o'clock your time, 1 o'clock here in the United States on the East Coast. Thank you ever so much. This was fantastic. Absolutely fabulous. The vast majority of the audience stuck through us all the way up to right now. Again, please fill out the survey. And one quick announcement, there is on the website a discussion of having a webinar on December 8th. There is going to be a webinar on December 8th, but it's just not going to be another episode in this series. So stay tuned to your mailboxes, your email. Patent Informatics is going to do a patent landscape study on the metaverse. This is something I wrote about in Forbes, and we're going to take that opportunity to go ahead and do a patent analytics webinar and then get back to machine learning for patents at the beginning of the new year. But again, you'll get information. I'm very, very happy to say that Andrea Davis from Botkin IP is going to join me for that one. She's going to be my host. But guys, thank you ever so much. This was a fantastic session. So much detail, so much information. And I don't think we could have asked for anything more about giving transparency and insight into exactly how the system works. So thank you very much.
Thank you, Tony. It was a pleasure.
Thanks, everybody.